I have a lot of screens opened. It's just not good. Hello. Hi. Hi. Ransom. How are you doing? Um, Nice to have you back. This is day 80. Um, Hold on. I need to quickly fix. Yeah. Oh my. Really, I actually forgot to take this off. Ah, God. Yep. We're back again. All right. I've actually created a Discord server. So I'll be sharing the link with you guys so that you can join the server and we can interact more there. So, all right. Yeah, let's continue studying what was I trees. Okay. Yeah, we are doing trees today. Um I have so here's an implementation I made yesterday. We'll go over this. We'll understand certain things. We'll probably solve one lit code question today. All right. Okay, so I'll make the Discord link here. Let me make a post on YouTube so you can have access to the um let's see. Dun, 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 dun. Okay. So here I'll make a post community. Let's come here. Hello guys, kindly join the Discord Discord server for more interaction. Interactive study sessions. Okay, I will put the link here. So here is the link. This is the image I use for the Discord channel. The Discord server. It's a very funny image, but anyways. um, the link to the server. Share link. Invite people. Okay. All right. Copied. So join here. Okay. So post. All right. I just made a post on YouTube, and let me share. Published. So share this. Copy. Dun, 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 dun. Okay, so I'm sure. Can you see the link to the Discord server on the community tab? If you go on my channel, you'll see it there. I'll also link it in my channel description and every video's description. So let me customize this, and I'll say branding, basic info, join. Okay, so Discord server is here. Discord server is here. So publish this. All right. And then in this video, I'll also edit it and put it in the description. This will be my Discord server. Save, and I'll put it here as well, so you have access to. Okay, yes, nice. So let me know. I'll check later and see. Let me even link it here. So here is the link. All right. So today, let's get started. Let's get right into the business of trees. We want to continue learning about trees, and we have quite a number of things to still learn, right? And I've not solved any lit code questions on trees, but there is no pressure. We are not being chased by anybody. All right, so slow progress is sure progress. Da, da, da. Okay, so let's get started. Now, I made a basic implementation of trees yesterday. We'll go over that today, and also look at a few other new things, right? So let me quickly recap. Yesterday we made an implementation of trees in terms of code. So here's the code for it. You can look in the description below to get access to the GitHub repo for the 100 days data structures and algorithm stream. All the questions I've been solving so far is included. All the questions are included in the GitHub repo, and also some basic knowledge as well, right? So we have the binary tree, which is something I covered yesterday. So we'll do it today too, and also solve a bit of questions and see some other implementations of it. Here is the code for a binary search. Like I said, the link is in the description below. You can have access to the GitHub repo. When you get to the repo, just look through the folders. You will see, the names of the folder, and they basically indicate what is in the folder. So, for example, if you want to look at for binary trees, right, or trees in general, you'll see the binary tree folder there, and then you can expand it and look at the basics. So you have access to this code here. Okay, so let me close all the other ones. Here, repeated DNA sequence. All right, so here is an implementation of a binary tree. Now let's quickly recap the basic terminologies in a binary tree. So first of all, we know a binary tree a binary tree is made up of a lot of parts, right? Different parts. Why is this thing not working? Okay. So we have the different parts of a binary tree. We have the roots of the tree. We have child nodes, right? Okay, let's call them children. We have leaf nodes. We have what else do we have? So within the children, we can have the right child and the left child. So I'll just put right and left. We have what else? Leaf node, child node, left and right children. Well, a child node can be a parent node if it has children node, right? We have the height of the tree. The height of the tree is basically the distance. Hold on. Okay, I think my Discord just made a noise. Let me quickly I'll mute that for now and I'll check it later. So I'll close this. Oh, hello code lifey. So we have the height of the tree is basically how many nodes, um, the longest distance or the longest path from the last node to the tree node in the entire tree, right? So it's just basically the longest distance between the left subtree and the right subtree. So we have something called subtrees. Okay, so we have subtrees as well. Subtrees, and subtrees will be on the left and right side, right? So will have the left subtree and the right subtree. So those are like very basic terminologies. So this will be the sorry, length from the last node to the root node, right? To the root node. And the size of the tree is the amount of nodes we have in the tree, right? So we also have size, which is total nodes in the tree. All right, so here are the basic stuff that we need to know off head, right? Basic terminologies. So the next thing to do is to let's represent a node and quickly identify those parts. So we'll have let's represent a tree, sorry. So we have a tree like this. I'll use A and alphabet letters to represent the values of the node in the tree. So here we have the left child and the right child like this. So we have here, and these nodes too have their own children, right? And this one too will have its own child like this. So this will be B, C, D, E, F, G. Okay, so now when you look at this tree, right, this part here or these two nodes that do not have any children node will be called the leaf nodes, right? So these are the leaf nodes. This is the root node. Right? Here is the left child of the root node. And this is the right child of the root node. Child of root node. Okay, so we have left and right child of the root node. So and every node here has its own left and right child. Now all the nodes will not always have children, right? Like in this case here, this leaf node here does not have any children, but due to the properties of nodes in a tree, right, they have other properties as well. So the left and right node will be null at first or none In this case, depending on the programming language you use, but let's just use null for now. So meaning the left and right child of this node C here are still vacant, right? They are empty. There is no left or right child, so which is why it is null. So and insertion of nodes in a tree is done in an ascending form. In other words, it looks sorted, right? So we have smaller values on the left side of the node of the tree. Sorry. So all the smaller values, and by smaller values, I mean values that are less than the root node, will go on the left side, and values that are superior to the root node will go on the right side, right? So that's another thing to remember. And also we have, let me leave this here, we have something called the node itself, right? Now the node itself has three properties. The node has a value, the node has a right child, like I said, and a left child. Now by default, these are going to be null, right? Null like this. Until there's a right child, the right child will become a separate node with its own children, if there is. Otherwise, it's just going to have null children as well. So the value is the value of our node. In this case, if D was the value of this node here, then D is the value that will be set here, right? So this is how the node object really looks, you know, on a bigger scheme, right? This is how it looks. We have values, we have right, and we have left. So these are one of the stuff you want to take note of. Now let's take a look at some nodes here. So let's say we want to insert these values, the following values here. I'll write out these values. So let's write 10, 9, 6, 14. Let's put 16 here. Let's say this is 13, and let's put a 5 and 8. Now we want to insert each of these values into a tree. Now here's how the insertion is done in a tree. First of all, we need a root node for our tree, right? You know, even in normal life, right, every tree has a root. So by default, when we create, so the nodes and trees are basically classes that we instantiate, right? So when we create an instance of our tree, at that point the tree does not have any roots. So when we insert a value into the tree, that first value becomes our root, right? So here is the first value we have here. So obviously this 10 here is going to be the root value, right? Or the value of our root node. Then we have 9, right? Now here is one interesting thing that happens where we insert values in a tree. There is a comparison that is done in order for us to know where exactly to insert the new value or to insert the new node. Now since 9 is less than the root node, right, it means the node that will be created from 9 will have to be the left child of the current node, which in this case is the root node, right? So we'll insert 9 as the child of 10. So we'll have it here. Now again, this is simply a node. This will have its own left set to null at first. Right is going to be null. And the value here is going to be 9 in this case here. So which is what I just did now. So 9 itself is not just a value that we insert in the tree. It's a node, right? We create a node from the value 9, or we create a node and we set the node's value to 9. The node has other properties as well. So we continue again, right? We continue iterating through this list of numbers. Now in this case we have 16, so we know what happens when we see a value larger than the current node, which is the root node in this case, right? So the root node will have a right child in this case, so this is going to be 16. 16 will be inserted as the right child of this node because 16 is obviously larger than 10. Then we see a 14, right? Now 14 is larger than 10, but then 10 already has a child node, meaning has already has a right child. So this is the right child of 10. Sorry, I'll use a different color to denote the right child. So this is the right child of 10. So meaning the next value we want to insert will obviously be in the right hand side of this root node, but then there is already a right child for the root node, so we move on and then set the current node as the child node of this node. Now we also need to make the same comparison to know whether the current value we want to insert, in this case 14, right, we want to know whether this value should be the right child or the left child of this node here, in this case 16. So 16 will have I'll just trace the two lines to represent the child nodes. Let me use a different color. So since 14 is less than 16, 14 becomes the child node of 16, and to be precise, the left child node of 16, because 14 is less than 16. So we insert 14 at this point, and then we see a 13, right? Now, one thing you might notice is, or one thing you'll be taking is that we need to balance the trees before we insert any other value. Since 13 is still less than 16, 13 becomes the child of the next node, right? Meaning 14 here, right? So now 14 will have this 13 as either the left or right child node. In this case, it's obvious because 13 is less than 14, so 13 becomes the left child of 14. So we put 13 here, and then we do the same thing for the other node. This one is 5, so 5 will be here. 5 is less than 10, right? We make the check, or we make the comparison from the bottom, from the top, or let me call this, from the root node towards the children node, until we get to a point where there is free slots, right? There is either a free, which is, by free I mean the left or the right child node of the current node that we arrived at is either is null, right? So the left and right child is null. So we have to make those checks at each point. The left and right are, not is. So the left and right child nodes are null. So in this case, we want to insert 5 in this tree, right? So to insert 5 in this tree, we come here, we compare 5 to 10. 5 is less than 10, so it goes to the left hand side. 5 is less than 9, so it also goes to the left side, or it becomes the left child of this 9 here. So this will become 5. And then again, we have 9, we have 8, right? So we want to insert 8 in the tree, so we go in this direction. 8 is less than 10, 8 is less than 9, 8 is superior to 5, so 8 becomes the right child of 5. So this is 8 here. So this is what our tree will look like at the end of the day, once we are done inserting all this value in the tree. And I'll show you how this is done in terms of code. So yeah, this is something we need to keep at the back of our minds. And another thing to note is we can't have duplicate node in a tree, right? So it is impossible to insert two nodes that have the same value in the tree, right? This is not going to work. We don't do that in terms of trees. So we only insert distinct values in the tree. And by distinct values, I mean we create nodes from distinct values, and then we insert those nodes in the tree. Okay, so I'll put here no duplicates node. All right, so let's move on to something else. Before I move on, let me quickly show you how insertion of values is done in the tree. So we'll write out some functions, right? We'll write some functions. Let me create a file. You know what? Let's use the playground and play around with this. Okay. So we know a tree is made up of nodes, right? So basically we are going to be creating instances of nodes. So let's create a node class. So we'll call this class node, right? This is going to be a node, and this node will have 3 properties. So first of all, when we instantiate this node class, we need a function, a constructor function, and this function is going to take a value, right? So let's say this is going to be, so here are the properties of this node class. This will first of all have a value. So self.value is going to be this value here. Self dot right, which is the right child, is going to be the same as self dot left, and they will all be equal to none at first. So this is the same thing as assigning none to both right and left properties on separate lines. So I just want to make this a single line, right? So now let's create a class for our tree. So I'll call this binary tree, right? Now this binary tree will need a constructor function, or the init function here. So we'll say init self. Now we'll need some properties for this tree, and the only thing we need here is just the roots. So we'll call this self.roots and set the root value to none. Now we need an insertion function. So we'll say insert node, right? Insert node like this, and we will need the value for the node. So we'll just put in value like this. And what do we need to insert? How do we insert a node? First of all, we need to create an instance of the node. So I'll say new node, new underscore node, and set new node to be equal to the node class, right? So we create a node, and we need a value for our node. So this is going to be the value that we pass into this insert function here, or method in the case of classes. So this insert method, we pass it a value parameter, right? And then this value would then be passed down. This value would then be passed down to the instance of node that we created here. So this is our node class. So when we instantiate the node class, we pass it a value, right? We pass it a value instead. So once this node is created, we then begin to insert it into the tree. But then mind you, I said before we insert any node in the tree, we have to ensure that our tree has a root node first to begin with. So we will say if the root is none, right? Meaning there is no value in the roots at this time. So we just set the root to the current node, self.roots to be equal to new node, and then we return. So now this return here is simply to end any further operation happening in this function. So once there is a root, right, we know for sure there is a root, then we can begin to insert other values at either the left hand side of the root or the right hand side of the root, or I'll say left subtree. Let's call it left subtree and right subtree. So we'll use, first of all, I'll just say current node. I'll call this the current node, right? Current node. Okay, I don't like doing it that way, so let's just say current node is equal to self.root, and we'll do this. We'll say if okay, so we need an iteration to insert the values, right? So we'll run a while loop. As long as this while loop is still running, meaning as long as we don't terminate the while loop within our operation, we keep continuing, right? So while this is true, so we'll check for the current root, right? So we'll say if the current node dot value is less than our value that we are trying to insert into the tree, then this will become the left child, right? So if this is less than the value, then we'll check if, so we are going to insert it on the left side, right? So if this root node is okay, so the value is now superior to the current node, right? Okay, meaning if it's superior, then we want to insert it on the right hand side. So we'll say if current node dot right is none, right, meaning there is no node on the right hand side or the right subtree, then we'll do this. We'll say current node dot right should be equal to our new node, right? So we'll say new node, and then we'll break the iteration at this point. Else, if it's not, we keep moving down the right subtree until we find a point where there is no right node, right, for a particular node in the tree. So we'll say current node dot right should be current node should be equal to the current node dot right. Otherwise, if the current node value is less than is superior to our value, right? If the current node value is superior to our value, meaning if in this case, if the root node is superior to the value, right, we want to insert the new node on the left side, right? So let's say we have current node. So we'll need to check again if the current node has a left side. So if current node dot left is none, right, then we want to insert the value at this point. So I'll say current node dot left is going to be equal to our new node, and then we break, right? Otherwise, else we can say current node dot left, current node should be equal to the current node dot left. Okay, so here is the code for inserting a node in the tree. So first of all, we need to ensure the tree has a root, right, which is why we make this check here. Now once the tree has a root, we'll then decide if the new node we are trying to insert in the tree is whether we then need to decide if the new node we are trying to insert into the tree will be a left child of the root node or a right child. Now, what are the conditions for a node to become the right or left child of another node or a parent node? Well, the value of that node has to be less than the current node that we are looking at. In this case, if the value is less than the right node, right, if the value here, this value If our value is superior to the current node value, then it will become the right child node, right? Otherwise, when the value is superior to the current node, when the current node value is superior to the value, sorry, when the current node value is superior to our new value we are trying to insert into the tree, then we insert that value, we create a node with that value and insert that node on the left side of the tree. So this is, the insertion of node in a tree, and which is what I did yesterday. So moving on, we are going to learn about traversing a node, right? Traversing a tree, sorry. Traversing the tree. And I think I have some things prepared here. Traversing the tree. So we have different types, different ways through which we traverse a tree, right? So we have a pre-order traversal, in-order traversal, post-order traversal, and so on. So we are going to take a look at the pre-order traversal. Now, the pre-order traversal is a type of depth first search where the nodes, pre-order traversal is a type of depth first search where each node visited in a certain order. What am I saying? Hold on. I need to make this a little closer. So, pre-order traversal is a type of depth first search where each node is visited in a certain order. Okay. So, read more about tree traversal in general here. So, let's see what this is. So, tree traversal is basically visiting every node in the tree. And we have three types. We have pre-order, in-order, and post-order. So, here is the reading we need to make here. So, going through a tree by visiting every node, right? One node at a time is called traversal. Since arrays and linked lists are linear, since arrays and linked lists are linear data structure, there is only one obvious way to traverse these. Start from the first element or the node and continue to visit the next until you have visited them all. But since a tree can branch out in different direction, which means the tree is non-linear, there are different ways of traversing the tree. There are two main categories of tree traversal methods. So we have a breadth first search and a depth first search. A breadth first search is when the nodes on the same level are visited before going to the next level in the tree. This means that the tree is explored in a more sideways direction. Okay. And depth first search. Depth first search is when traversal moves down the tree all the way to the leaf nodes, exploring the tree branch by branch downwards in a downwards direction. So here are the three types of tree traversal. We have pre-order, post-order, in-order. So here's a little exercise. In a binary tree data structure that we're below, right? What is the relationship between B and nodes E and F? So B, E, F, right? E is B's right child, right? Oh, sorry, left child. Let's do this. And F is B's right child. So this is, oh, okay. I'm not going to do all of that now. I just wanted to do that for fun. Let's see if there are any questions in the chat. I'll pull up the chat now. Let's refresh the page. Hey, so okay, there are no questions. Okay, let me close the chat again and come back to my screen here. All right, so we have, wow, time is really going fast. Today I will need to have more engagements with you guys on the Discord server and see, how we can move things going forward. So let's take a look at a pre-order traversal. Pre-order traversal is a type of depth-first search where each node is visited in a certain order, right? So we visit every node in a particular order in a pre-order traversal. So this is how it looks, and let's see how it works. Pre-order traversal is done by visiting the root node first, then recursively do a pre-order traversal of the left subtree, followed by a recursive pre-order traversal of the right subtree. This is used for creating a copy of the tree prefix notation of an expression tree. Okay, etc. This traversal is pre-order because the node is visited before the recursive pre-order traversal of the right node. Did you say the right node? The node, okay. The node is visited before the recursive pre-order traversal of the left and right subtrees. Okay. So this is how the code for pre-order traversal looks like. So let's see. So we define the pre-order traversal function. If node is none, then return. Otherwise, keep calling this function. So this will call for all the left node, right? And this will call for all the right node. Now, when you are calling for all the left node here, when all those left node are done within this left node here, right, the right node will be called, and the same thing will happen for this right node, right? So here's like a deep recursive call. Okay, I like and I don't like it. uh Recursion is actually very funny because you really need a base case to, terminate the recursion or the recursive call. Otherwise, your function will keep calling until, your program crashes. So we need to be careful of recursion. And the base case here is this. So once the node no longer has either a left or right child, or once the node at that point is none, right? It could be the left node of a particular node or any node in a subtree. And once that node is done, we terminate the iteration, or we terminate the recursive call. So let's read how it works here. So the first node to be printed is node R, as pre-order traversal works by first visiting or printing the current node. Yes, obviously the current node will be node R, which is going to be the root node. Okay, and then we'll call this. This will call this and call this. So we'll go from R to A to C, then we'll go back to A and then call D. Then R's B will happen here and so on. So left before the right. So let's see how it works. That's just my imagination. The pre-order traversal function keeps traversing the left subtree recursively on line 5 before going to going on to traversing the right subtree on line 6, right? This and that. So the next nodes that are printed are A, right, and then C, okay. then we go back to A, then D, right? So A and C. Okay. So the first time the argument node is none is when the left child node of C is given an argument and C has no left child. Okay. After none is returned, the first after none is returned the first time when calling C's left child, C's right child is also returns none, right? So C's right child will return none. Then the recursive call continues to propagate back so that A's right child, which is D here, right, is also checked. So it's printed next. The code continues to propagate back so that the rest of the nodes in R's right subtree are printed as well. So let's have a look at an implementation. So I'll write some code here. So okay, so I did a pre-order traversal already, right? I did a pre-order traversal, which is why I'm talking more about it. So I really had an idea before doing this. So here is what needs to happen. Let me just comment this out. So we recursively call the functions, right? So we'll do pre-order traversal. We call pre-order traversal for the left node of the current node. In this case, we'll start from the root node, right? And then we'll print every node until we'll print every node on the left, right? And then I'm just using this result here to append the values at each point. Otherwise, we can do this, right? Let me just remove this part. And then we just print the nodes, right? We just print the nodes. So as you can see, let me draw. Here is my parameter. I have 100. I'll copy this, and then I'll represent the tree. Then we'll write out how the nodes are going to be printed out in a pre-order traversal. Then we can verify, by comparing with what the function outputs. So I'll paste this here. Let me paste it here. So here is our input function, our input array, and we want to insert each one of these elements into the tree. So let's get started. So I'll create a tree, a very simple tree here. So the first node we'll have in our tree will be a node with value 100, right? A node that has 100 as its value. So we'll have, let me just write this out. This will be 100. Now, since we have more values, I just assume there will be a left and right child for this root node. So here's our root node, right? Now we want to insert 100 in the tree. 101, which is the next value here. So 101 will go here, will go on the right hand side because 101 is superior to 100, right? It goes on the right. 99 goes on the left. 97 is less than 100, so it goes on the left. 97 is still less than 99, so it goes on the left hand side of 99. So we'll put 97 here. Come on. 97. We have 86. Obviously 86 is less than 99. 86 is less than 97. So 86 is also the left child of 97. So put 86 here. Then we move on to 140. So 140 will come to this right hand side. But 140 is still less than 101, so it becomes the right child of this node. 140 here. Then we have 120. 120 will become the left child of 140 because 120 is superior to 100, is superior to 110, but in this case it's less than 140, so we'll put it here, 120. And then we have 44. 44 is less than 100, is less than 99, is less than 97, less than 86. So it will become the left child of 86. So we'll have 44 here. So this is what this array would look like in a tree form, right? It's not really pleasing to the eye, but yeah, this is what happens when we insert with this code here, when we insert each node in the tree. Now let's see how we can traverse and print out every node in the tree. Now, using a pre-order traversal, we want to recursively print out every node in the tree, right? So we'll first of all start from the right hand side, right? So we'll start from the right. A pre-order traversal goes this way, it goes in this direction. So we first of all print all the left child of the tree going down before we begin to print the right children node. So let's see, for this tree here, we'll have 100 at first, then we'll go from 100, we'll come here 99. 99 will be called recursively, and every node here will be printed. So we'll have 97, and then we'll have 86, then we'll have 44. Then we'll come to the right side and print the left child node of this. So we'll print the right, first of all, the right of this node. This will be 110 or 101. But this node does not have a left child, right? Otherwise, we would have printed this left child before coming back to this side. So we continue with the right child, right? And this will print 140, and then we'll have 120 here. So this is what the results will look like at the end of the day after we run the traversal function. But you know what, don't take we need to verify that, right? So I will quickly run this function. So we have a pre-order traversal. We pass in the root node because we are inserting every values here. So we instantiated the tree, binary tree here, inserted these values with this loop at this point, and then we'll print out the values. So I'll remove this here. I was using this result to print out the result actually. So you know what, let me do that again. I'll bring it back and we'll run this function to see. So you can see, oh my god, what have I done? I'm in debugger mode, right? Let's just run this function normally. I'll copy this part and we'll look at it in terms of, we'll compare it to this one, right? And see whether the concept of pre-order traversal was properly understood. So let's compare the values. Now you can see after we made our insertion, we'll have different nodes, right? So here's how we'll print out the nodes. So here we have this and that, which is correct. This is also correct. Here 97, 97, 86. Okay, this is good. Yeah, so the nodes are printed correctly in a pre-order traversal form. So this pre-order traversal is a breadth first search, right? Let me be sure of that. So okay, it's a depth first search, sorry, depth first search, because we printed every node on one side down the tree before going to the other side to print every node on that side. So this is what we call DFS, depth first search, right? DFS. So we have a question here on trees in linked on LeetCode, and I'll quickly read this and see if I can explain this before the time runs out. I have like 2 minutes left. Oh, my time is actually up. Okay, so let's see how we can solve this question. I'll quickly explain it and see what we can do. So you are given the root of a binary tree, right? Binary search tree. Okay, sorry. A binary search tree, BST, and an integer value. Find the node in the binary search tree that the node's value equals val, right? And return the subtree rooted with that node. If such node does not exist, return null. Okay, so based on my understanding of this question, let's see what we have. So we'll be given two inputs. We'll be given the root of a tree, and then we'll be given the value, right? Now, so to search a value in a tree, right? We need to traverse the tree, obviously, but the traversal will become easier if we can continue comparing the values, right? Basically, this is what I mean. Let me come here. And I will increase this, right? So let's say this is a tree we've been given to search, right? We want to search in this tree. We want to search for a value in this tree. Sorry, a minute, please. Who are we trying to search for? I think let's look at this here. So we are trying to search for 2 in this tree. And then once we find 2, we'll print the subtree from 2 all the way down, right? So now how do we search for the value? Well, we know we can um we can traverse, the same way we traverse the node, right? To insert a value. So we can still do something like that, but this time around we can check at each point whether the value is equal to our current value, right? So, or whether the value of that node is equal to our current value, which is the second input of this function. So when we start at this point, right, we first of all need to be sure that this node here has a left or right child. If it has a left child, then we need to be sure that so if it has a left and right child, we need to compare, the current value, the input value, which is val. Val is equal to 2 here. Val is equal to 2. So we need to compare val with this root, right? This root value. So in this case, let me quickly erase this. Val is equal to 2, right? The value is equal to 2. And value is obviously less than 4, right? So meaning we have to search for value on the left subtree of this tree. So what we need to ensure after comparing to the node value, we need to be sure that this current node has a left child, right? Or has a left subtree. So again, we'll say val here, val which is equal to 2. We'll compare val to the left child, right? Now if val of this left child is true, then we can just return this particular portion of the tree. Now we know the left child of this root, right, is everything connected to that child. So we can simply return the root dot left. So this will return the root dot left, and we know the root dot left automatically has a connection to other nodes, right, in the tree. So yeah, this is what we need to do in this case. Now the time is up. I think I'll provide the code for this tomorrow, or I can put it in the Discord server for us to even talk about it more. um so it was a good session today, and please guys, join the Discord server so we can interact more and solve some more lead code questions there. And this will also provide us with a better space to share our blockage, or so, the issues we face trying solving a question. And if anyone knows how to solve that question, they can assist others, right? So it's a place to assist and share knowledge as well. And I hope we keep the server a nice place for others to interact with us. You can meet other people there, help people if you can, ask question if you are blocked with anything, right? Anything related to programming. If you don't know anything, you can ask a question in the server, and yeah, if anybody can help you out, they will. Otherwise, I can jump in myself and help you if I have the time. So anyways, it's been nice streaming today. Let me quickly share. So we have some questions here. I think I have some server. You can request you can request for some. So I have a programming help, right? So there is a PHP, JavaScript, Python channel where you can ask questions that are not directly related to data structures and algorithm, right? And if anybody knows how to help you out, they will. And also we have a general channel where you just come in and say discuss other stuff. We have a lead code channel as well, right? I don't know if I should open this here. Oh, I've closed it again. Sorry. We have a lead code channel where you can also discuss. Let me put it this way. I think you can see my screen from this point. So I just wanted to walk you through certain parts of the channel. So we have a general channel where you can interact with people, meet other people, discuss ideas and so on. And this channel is where I'll be making announcements and be posting recording sessions. We'll have the welcome channel as well. I don't know what I'll do here. This is my first time creating the Discord server for a lot of people. But yeah, so we have the DSA or coding category as well. There's a channel for leads code questions. There's a channel for general DSA question, not necessarily leads code, but um, other data structure related questions. And we have programming help, right? So here you can help others, or you can post questions that you have. If you have a question, you have something blocking you in PHP, right? You can post your PHP related question here, or JavaScript, any JavaScript framework as well. You can post your question here. Python related questions can come in here, right? And C# as well. So the link to the Discord server is in the description. You can share this with your friends. You can ask others to join so we can help each other out and grow as one big community. Anyways, it's been nice having fun with you guys, recording this section today, and I hope to see you in the channel, on the server, I mean. And any question you have at all, it might not be necessarily related to data structures and algorithm. As long as you feel you need help, you can ask. And when you also come to the channel, if you can help someone out, that would be really nice, so that you can also help others. This will not only serve as a way for you to grow as a programmer, it will also open your mind and give you connections to others. You can network with people as well. And yeah, so basically that's all it is, and I hope to see you guys soon. All right, take care and see you tomorrow. Bye.